Hi, I'm Taylor Veltrop, and here's my robot, Veltrobot. Today we're going to show you a robot teleoperation demonstration using the Xbox Kinect. Some background information on this robot. It's built from a Kondo KHR1HV kit. The computer is an embedded PC called the Roboard. It communicates with the host computer over 802.11n networking, and the host computer is attached to the Xbox Kinect. The control system on the robot and on the computer is implemented in ROS, the robot operating system, by Willow Garage. The Kinect software is from the Night package, and all of the code that's being used today is available for free download. You can get more information on my website for how to download that. And without further ado, let's get to the demonstration.
So we're all up and running now, and the robot's waiting for commands. The robot has to be laying down for starting because once the Xbox Kinect syncs up with me, the arms are going to go wild. So, to calibrate the Kinect, I have to put my arms up. And here we go. Whoa, that was very surprising. So, I'm going to try to do some push-ups here. But, too bad. Let's try again. Okay. Gotta get up. And 1, 2, 3, 4, 5, 6, and 7, and 8. Okay, you get the idea. So, stand it up, and the robot's got some gyro sensors so it can do some dynamic balancing. Without that, there's no way it'd stay standing up. You can tell how important it must have been to have the virtual model to work with. Otherwise, when I was programming this and getting all the geometry right, the robot would have destroyed itself if I had to use the real thing. So, it's a pretty good approximation of what I'm doing with my arms. And you'll notice the time delay that happens when I move quickly is between myself and the Kinect skeleton sensor, not between the model and the robot or the skeleton and the model. It can move pretty quickly. Now there are some problems with the simple geometry I'm taking out of the skeleton to apply to the servos. For example, if I move my arm backwards, the robot moves its arm forwards. There's also some ambiguities in the positioning of the servos. For example, if I have my arm up, there's two ways the robot can get here. It could be 180 degrees around one joint and 0 on the other, or 180 degrees on the other and 0 on the one. Shoulder pitch and shoulder roll. Another problem with trying to directly translate the skeleton's joint angles into servo positions is that if I want the right arm to have two right angles in it here, in real life now my right hand is past my left shoulder, but on the robot the right hand is still on the right side of the chest. So there's too many compromises with using these skeleton joint angles directly. Better approach would be to take XYZ positions of the hands and calculate inverse kinematics all the way up the arm and have the robot choose its own joint positions. Additionally, I'd like to track the opening and closing of my hand to see if I could control the robot's grippers. But I think this is a pretty good start. So now I'm going to move around a little violently and see if we can make the robot fall down. Well, that's that. Thanks for watching.